Hello class, this is the first video covering activities 5.7 and 5.8. These activities are meant to serve a brief introduction to radical functions. So we start with an example. When an object is dropped from a height d, right, so the height is d, the time t in seconds that it takes for the object to hit the ground is given by the following equation. So this is similar to what we did in chapter 4, where we were on top of the Sears Tower, we dropped the ball, and we had an equation that gave us the height of the ball at any given time. We now have a different equation that also describes the height and time relationship. Okay, so if the question 1, it says the Sears Tower is 1,450 feet tall, so if the object's dropped, so the value d in this case would be the 1,450. How long will it take to hit the ground? Round to the nearest hundredth of a second. So if we place the distance, 0 in for d, we can get the time, right? And then we can place the 100 in for d and the 200 in for d and so on, and come up with the time. Okay, so let's do this. There's a long way and a short way to do this problem, right? Let's take out our calculator. The long way would be to actually type in 1 divided by 4 and then multiply that by the square root of 0. And I press enter, and you see you get 0. So for the first box, we'd actually write a 0 in here, right? So 0, right? And then for the next box, we would do the same thing, except instead of times the square root of 0, we place a 100 underneath the square root sign, right? So I'm using this formula, and I'm replacing d with these values, 100, 200, 300, and so on. So now you see we have 2.5, right? And then, all right, so that's one way to fill in this table. The other way would be if we actually go to y equals, right? Clear everything out. And I can put in 1 divided by 4, and then we're going to multiply the square root, and we'll call this x. So instead of using d, we'll use x. And if I set up my table, right, I press second window, right, table set. So I'm going to start at 0, but instead of counting by 1, let's count by 100. Right, so or actually, since we need this 750, let's count by 50, right? So we'll go 0, 50, 100, and so on. Now, when I press second and graph, you can see when my d or my x is 0, my y is 0, right? When we have d is 100, you notice we have 2.5. And then for d is 200, it's 3.5, and so on. Now, this did say round to the nearest hundredth. All right, so I'm going to fill in my table with the values from my calculator. So for 200, it's 3.54. Oops, my touch screen's not working. There we go. Right, and for 300, we have 4.33. And 500 and so on, okay? And 500 is 5.59. And then I want to scroll down because we have to get all the way to 750, I believe, or 1,000. So I'm just going to keep pressing the down arrow. There we go. All right, so now we have the values for 500, 750, and 1,000. So let's write that in our table. Okay, so my table is now complete. To use a table to determine an appropriate window and graph this. So for my window, think about it, my x-min, I'm going to use 0 out to 1,000. And for my y, I'd go from 0 to maybe 8. So if we're going to graph this, we already entered the equation, right? Y equals 1/4 square root of x. My window, I'm going to go from 0 to looks like we went to 1,000, so maybe I'll go a little bit bigger than 1,000. Maybe I'll go 1,200. All right, so I'll write 0 to 1,200. And then for my y, or in this case the t, I'll go from 0 to some number bigger than 7 point. Let's go to 10. Okay, so, and then if you wanted to change your scale, instead of having 1,200 tick marks, maybe we'll count by 100, and we'll only have 12 tick marks. I press graph, and there's my sketch. Okay, so on your paper, you know, they want you to kind of sketch the graph and label the axis. And, you know, I'm using a touch screen, so what I'm about to do is not going to be a Picasso, but, you know, just do the best you can. Right, here's my graph. This is my D, and this was my T. Right, so and this was in feet. Right, and this is seconds. And then the graph did something like this. And again, hopefully you can draw a better graph. I'm using a touch screen, so as you can see, mine's a little sloppy. Okay, but those are my axes, right, labeled. Now it says, okay, what's the domain of the function? Well, if you think about it, if I were to say what's the practical domain, you might say from 0 to 1,000, but it looks like the actual domain, right, it's really all of the values of x that are valid here, well, it can't be negative, right, because I can't have a negative under the square root sign, right? So x has to be positive. So I would think that x can be any number greater than or equal to 0, right? And when I look at my graph, you'll notice x does not go to the left here, right? If I change my window and let's say I make a negative, you know, the book doesn't ask us to do this, so this is bonus. I'm just going to increase my x min to negative 300. Notice how my graph never, right, the x values never become negative, right? It's always 0 or greater. All right, so the domain, the values of x that are valid for this graph, and it has to be 0 or bigger, because we know we can't have a negative sign underneath the square root sign, right? And then if you think about the y, well, the 1/4 is always going to remain positive, and the square root will never give me a negative number. So that means the y values have to be greater than 0 as well. Okay, so let's do that. Y is going to be greater than or equal to 0. Okay, so the range, all numbers that are equal to 0 or bigger, and the domain would be x has to be 0 or bigger. And again, you can see this from the graph, right? Y is never going to be less than 0, and it goes up to infinity, and the x starts at 0 and also goes out to infinity. Okay? Then they give us a little blurb here. This is considered a radical or a square root function, and they ask us to remember that we can't take the square root of a negative number, right? It's not real. Okay, so whatever's underneath this radicand can never be negative. Okay? And then they give us the definition of the domain of a radical function. And I might ask you about the domain, right? I'll say, you know, what is the domain of such and such radical function? And then you're going to provide that for me. Right? So we'll stop here, and then we'll pick up with example 1 and some of these problems in the next video.